Welcome to the sixth lesson in reading and writing engineering research articles. In this lesson, we'll be looking at the last two divisions of your research article, finding the components in those. This is based on Chapter 6 of the textbook. Now remember that one of the things you may find is the testing methods. In IMRD, usually those are found in the last subsection of the methods. And often will be indicated by the title of the subsection. But in IPTC, frequently the testing methods are found in the testing division along with the results, and frequently in the same paragraph as the data and other components that we'll be looking at. Now, the data patterns form a large part of this division. And I specifically call it patterns because the data themselves are often worthless unless you can discover a pattern. And because we recognize patterns visually, those are often presented visually in either graphs or tables. And data is required in almost all studies, but again, if it's a purely mathematical study, depending on mathematical proof, then it may not be necessary. In IMRD, frequently the main points of the table are highlighted in the text, whereas in IPTC, often the writer simply points to the graphic and expects that the readers will be able to interpret it themselves. Now, data patterns come in many types. For instance, in this graph, you could say that this is linear, or that it's rising, or that there's a strong correlation between the two values, or that the new is better than the old at all of the points measured. So there are many different types of patterns, and sometimes you can have many types of patterns in the same graph. Now, comparisons is the eighth component, and again, this is usually present and in engineering frequently combined with the data patterns, and frequently thus presented in the graphs or tables visually. And it may be, again, explicit, or it may just be implicit in the fact that they show two lines on the graph. So what do you compare with? Well, sometimes there's a comparison with the expectations or the predicted results or some theoretical ideal. On the other hand, you may compare two different designs that have been mentioned in the same article, or you may compare with previous work, in which case it would require citations of that previous work. And then we go on to 9, interpretations. This is the main claim of a science article because this is where the explanation is found. On the other hand, in engineering, it may not be necessary because your design is based on some theory, and therefore you may not need to interpret your results. And then again, either components 8 or 9 are usually there, one or the other, because it's necessary to explain the meaning of the data patterns. The data never speak for themselves. You have to show that your explanation of the data is correct, or that the solution is best in some way. And then finally, the conclusion. The conclusion may include the summary of the design, it may include the achievement, or it may include future work, or perhaps 2 or 3 of those different subcomponents. And in many cases in engineering, this is a separate section, but it may also be the last paragraph in the discussion, particularly in the traditional IMRD format. So again, to summarize, we're looking at the claims that are in the last division. In science, that you have a good explanation for the data, or in engineering, that your solution is better than other existing solutions. To do that in IMRD, you need to look at the data patterns, the results, and the comparisons or interpretations in the discussion. And then, again, frequently in the modified IMRD format, there will also be a separate conclusion. Whereas in IPTC, you have the same sorts of things, but you also have the testing method, and often these various things, the testing method, the pattern, and the comparisons are all found in the same paragraph, again, followed by a separate conclusion. So this is the difference, one of the main differences between IMRD and IPTC in this division. So now we're going to let the TAs show you in their articles how they found the components and whether they fit the expected pattern. Okay, now we're going to look at our chemical engineering article at the last two divisions.
Okay, so this is the third division, result and discussion. And for the second division, they have two kinds of methods. One is material characterization, and the other one is electrochemical characterizations. So first is the material space. So the previous part of the results and discussion, they will show the comparison. So the figure they showed is in here. So as we can see that this is the image. So we can see that they always in the starting they say that the figure 1, the figure 2, and they say that what's in the figure 1. So this is a describe. And the purpose is to comparison. So this is a comparison component.
So it has both the data and the comparison in the same paragraph.
Yes. So if they are comparing the material, the data could be the image, right? So this could be the data.
Right. So the pattern here is not like a graphical pattern, but just the pattern of the two images. If you go back up there, like this one looks very plain, very flat, and this one looks very patterned.
As we can see in the next paragraph, they say due to the superior structural integrity shown above. This means that they want to connect the first two paragraphs to the following paragraphs, because the following paragraph is talking about the next testing methods, which is the electrochemical characterizations.
So the order of the paragraphs in the methods division matches the order in the results.
Yes, they should be like this. So what they listed in the method divisions, they should show it in order in the result and discussion division.
Right, that makes it easier for the reader to follow A, B, A, B.
Yes, and also the image also follows the orders. Yes. So we can see that they have the same patterns, that figure 3 compares, and which we can see that these all, we can see the numbers. The numbers is like they're describing the graphical here. They're describing. So,
and again, that's more common in IMRD, including chemical engineering, whereas in electrical engineering, sometimes they just say, look at the figure.
Yes,
and they don't tell you what to look at. We'll see that in the later papers.
Yes, because why they are talking about this one is because that there are only dots. There are only dots in the or lines. They didn't point out the specific number.
Yeah.
So they point out the specific number so the readers could know that if their data is better or poor than the articles.
Okay, good.
Yes. So we can see that there are some keywords inside this division. It's like compared or due to. Due to means that the interpretations components, and compares is the comparison components. And here we can see that there's also another keywords, should be attributed. This is really common in chemical engineering articles. This is really common.
Right.
And the next one is, this is the data patterns. This is almost the only one data patterns that have shown in these articles. This is
a plateau. A plateau is where it levels out. So
yes,
that's
yes,
a pattern.
Yes. So we can see that all the figures they have to explain. They cannot put the figures out and they didn't have any explanations.
Right.
So we can see that they have all the figures and explanations and why does the result will be like this, and we can see all here.
Okay, good. So each one compares, indicates, compares, indicates. So you have the comparison followed by the explanation.
Yes, because we have to do that, because if the comparison results doesn't have any explanations, then if anyone wants to like replicate or do it again, if they have failed, they could not know why.
Right.
Yes.
Very good.
So now there is also the same things. Now in the case comparisons explain much better performance is all similar. So now we can go through the conclusion part.
Okay.
The conclusion part that we have 3 components. In here we can see that in this paper we tackled. So that means that they describe the highlights in the first sentence, and then they give a summary that we really did it well. So the next one is that our approach is faster, low cost, because that they through the calculations and they achieve the research goal. And now they said it is believed that the performance of the electrode can be improved further.
Okay, now we'll look at the same things in our mechanical engineering article.
Okay, let me talk first. This is a testing divisions, and if you look at this section number 5, the name is simulation and experimental result.
So the simulations are like on a computer, and then the experiment is physical, real thing.
Yes, right.
Okay.
Okay, let's see the first one, simulation result. For this one, the title they use as a communist marker for the testing method, and then they will have the explanations how they carry out the simulation result. They compare with the traditional sliding mode control which they propose controller, and next they say they compare with these 4 figures. So it's a kind of a comparisons, and at the same time they also show the data pattern here. Next we go to the this component marker. We have 2 things in here. The first one is a comparisons. If you can see in this keyword, it's called 1.5 less than. So this one is represent the comparisons. Okay, between figure 3F and figure 4D. Okay, and because of this one, they indicate that so these the sentence after that they will show some interpretation.
Okay, so here you have both comparison and interpretation in the same sentence, not just the same paragraph.
Yes, right.
Okay.
Okay, right now we'll move to the experiment result. The first, and then they will show you the figure 5A. Is a picture here that is a experimental setup to show you that how to carry out the experiment.
Okay.
And as well, the below here also explains and describes how they carry out the experiment, what is the conditions, circumstance.
Yeah, like the parameters, as it says
Yes.
here. That's the input to the experiment.
Yes.
So this table is not results, but that's the parameters, the inputs.
Yes. And the other one is, as you can see here, have a figure 6 illustrate. As you have said many times about the testing method, the data patterns, they will have the keyword, something like the illustrate, demonstrate, show. So this one is very clear. This is a data pattern. And the other one is, this one is according to the experiment result for the circle trajectory tracking. This one, like, he tried to refer to this result, and then they will explain the interpretations.
So this one, compared to the one we looked at in chemical engineering, these results are really, really short.
Yeah.
Which again, that's what we expect in the IPTC format. The results are usually much shorter than they are in the IMRD, even though they're both different fields of engineering.
Yeah, sometimes it's compressed in only one sentence but contain 2 or 3 components.
Right.
Okay, let us move to the conclusion divisions. In this, we will have 3 types of conclusion. As you have mentioned, we will have 3 types. The first one is a summary. As you see at these first component markers, they say, and innovation robust controller has been investigated.
Okay.
So if that means what this paper have done, okay, and the sentence here they will explain what the detail, and then the second one is contributions. They try to point out what is the contribution in this paper, and this is the achievement.
Okay.
And the final one here is the third type is the future works, and the keyword is really clear here in future work, and then blah 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 as an explanations.
So again, just like in Wendy's, it has all three subcomponents of the conclusion in this. Okay, now we're going to look at the electrical engineering article. But remember here, we're looking at the middle of a section because in this article, it's a little unusual that it has the testing division sort of at the end of two of the sections.
Yeah, so as we talked before, in the subsection process, they will include a subsection called the experiment resource. So this is called the testing division in this paper. And we started at this 5C, is experiment resource. They will talk at the first, they will talk about the testing methods they perform into this machine, and then they compare with the DG methods. So it's testing components, and this is they will also say about along with 5K, and they will add 3 industrial K. So it's also the testing methods components.
Okay, so that's what they're going to compare against. They're going to compare against 5 cases plus 3 industrial cases compared with their method.
Yes, and in here is the net part, they will say the status of those case and the runtime for both methods as shown in the table 2. So this table will be include the data pattern and also the comparison.
Right.
And in here, we can easy to find the comparison component because they will mention for the case or for some case. So they will show some comparison of their work.
Okay, so every field has slightly different component markers that are common in that particular field.
Yeah, and in here they will explain the detail of their data and also the comparison, and we call that
interpretation.
Yeah, interpret. And another experiment resource in this paper is also in the subsection of 6 session. So it's on subsection 6D is also say experimental research, and they also mention about the testing methods component, and they propose the synthesis flow element in APC, and in here they will talk about the comparison and also the data pattern as shown in the table 3. And in here they will very clear, they talk about comparing to the unknown synthesis for most of the case. This will be the comparison components.
Okay, so again, here you have mostly comparison. You don't have much interpretation because it's built on established theory, and you know what to expect. You don't need to explain why you're getting the results.
Yes. And in next, we will go to the conclusion of this paper. And at the first, they will summarize what they are doing in this paper, and also they will show the efficient of that paper is like their contribution in their work, but they didn't show the future work in their work. No.
Right. So it says like they're effective and efficient. So again, those help you to recognize their contribution, their achievement. But this one doesn't show the third of the 3 subcomponents.
Yeah.